Very good morning, dear spectators. I would like to welcome you here at the Innovation Days 2021. We're sending here live from our fantastic TRUMPF studio in Ditzingen. Hello, nice to see you here again. My name is Chris Brau. I would like to welcome you here, guide you through the talk sessions. Our first topic here today, it's all around the topic of welding with TRUMPF. So we talk about the current challenges and especially how TRUMPF products help you to face these challenges. And in concrete, we're going to look at 3 products from the welding machine portfolio from TRUMPF, among others. The machine that was just introduced, the TRU is a Weld 1000, a brand new machine that is really interesting. Don't miss it. And now you're again welcome to ask your questions in our chat window. And then afterwards in the Q&A session, we will reply to your questions. If it's not possible to answer all your questions, then afterwards we will reply to them and they will still be available for around an hour in the chat window. And in addition to that, in general, you can always contact us. Don't hesitate. Even if it's questions that have nothing to do with our session here, you'll find the contact, the possibility in your platform window. And what I want to tell you also is everybody here in the studio will stick with the 3G rules, the COVID rules, no matter if you're vaccinated or recovered. We test every morning, so safety first. Now let's get to the introduction of our experts, because I wouldn't be able to explain that on my own. I would like to welcome from the technical sales expert for 3D laser systems, Svenja. Good morning. How are you? I'm good, thank you. And our next guest is Dr. Christoph Turner, technical sales expert, robot welding. I hope you're also doing well. Yes, thank you, I am. So let's start. Let's get started with the first question. So what are the main challenges when it comes to welding? So best is to look at the welding and sheet metal industry, how it's typically carried out today. What we see here is a lot of manual welding, WIG, also MIG-MAG, but especially a lot of manual rework that is always necessary, sanding, polishing, cleaning, aligning the parts. And that leads to the fact that for welding, this process chain, in comparison with all the other process steps, we have normally very high costs, varying quality, and also it's very hard to plan for the companies. The main challenge in Europe, Germany, is this skills shortage. So we always have a lack of, workforce, and that is a problem. That seems to be a general problem, right? That we don't find enough workers, right? So what's the problem? The problem is very personnel intensive, so we need a lot of experts. Sometimes you could even call them artists. But on the other hand, it's also a job that is very hard and can even be an impairment for your health, often not very ergonomic working. And we have to admit that in the course of the last years or even decades, there have not been many innovations regarding that. So also the workstations are not very modern, not so attractive for young people, which leads to the fact, all these reasons that less and less young people want to learn how to weld. What can we do? What can we do to tackle that problem? The key word, of course, is always automation, right? Especially a robot can take over repetitive tasks. The workstation, the workplace becomes more modern. Let's call it, let's say, go away from the dirt, go to high tech. But for many companies in the sheet metal industry, that is not really, a long-term solution, because the problem is, many companies face the challenges that smaller batch sizes need to be produced in a flexible and in an automated way, and the high quantities. The currently available systems have the problem that they are so complex and complicated when it comes to programming and operating that, not only the welding expert is needed, but also a programming expert would be necessary. And if you have several hundred or thousands parts, only then it will, pay off. That's a problem we try to tackle we introduced the true arc weld, but very intuitive operation, very simple, and this makes it possible also that also smaller batch sizes can be automated more economically. So you say high-tech is not the only solution, right, for skills shortage problem. But let's look at a video that explains the programming. We see, in the video, the operator pulls the robot to the position where it's needed. And especially, the creation of the program is very simple. The path points and also the weld paths can be defined by just pushing buttons. We see on the left side that the program is automatically created, so the operator doesn't need to write anything himself. Oh, that means that even I, as an absolute layperson, could do that? I promise you, within 5 minutes you'll be able to make your first weld seam. You're very welcome to try that after that talk. Okay, let's talk about it after that session. The TRUMPF Weld 1000, how popular is it on the market? As I told you, we introduced it 1.5 years ago. It's very established now on the market already. So we've kind of, we struck kind of a nerve here. And TRUMPF went a step ahead. On the Blech Expo, on the exhibition, the relative machine has been introduced here, True Laser Weld 1000. So what is this machine able to do? This machine, we had like a similar target, quite a simple intuitive operation, but now transferred to laser welding. So for the first time, it is possible now that the entry to laser welding can be implemented using a machine with a very intuitive and simple operation. Also here we can show you a small video. We can also see here that the operation is done directly at the robot, but here with a so-called 6D mouse. So the operator pulls, pushes, rotates, or tips the mouse, and then the robot follows. You just push a small button. Program creation is done automatically. So you push one button, and respectively the weld path or also the movement of the robot is saved. Also here the operator doesn't need to learn a program code, there's nothing that he needs to program himself. It's crazy, right? It looks so easy. Is the rest of the handling as easy as that? Yeah, also the rest of the handling of this machine is extremely simple. The machines come mounted with a forklift truck, installed on the installation surface, and mostly customers can start welding just after a few hours, so only just after arrival of the machine. And for me as a layperson, a question, what is better, what is more suitable as a tool for the customer? Let's say the arc welding or laser welding? I mean, first, all the approaches, of course, have their benefits, their pros and cons, so also their justification. So arc welding, especially in the sheet metal industry, MIG, MAG and WIG welding, have, especially they offer benefits with manual work and with difficult accessibility. If one, let's say, operator needs to go somewhere into a difficult corner, and also if additional material needs to be applied. When we talk about laser welding, the question is where, or from this high quantity of applications that are done with arc welding, which of these applications would be better with a laser? So where could we here utilize the benefits of the laser so that the parts can be produced faster, cheaper, higher quality and quantity? Yeah, to clarify this, I've brought 3 samples here. One essential benefit of the laser welding is the high welding speed, and we get, less distortion also. You see, this one here is laser weld, and there's a little less distortion compared to the arc weld one. You can see that immediately. And we can also look at a video how fast that can be produced. We have a short video sequence here. We see laser weld part. It only takes 4 seconds to weld it. And when we compare it to arc welding, it takes almost a minute to make the same part. And with arc welding, it welds, and we see in the end how much distortion we get here. Do you have some more samples here? Yeah, exactly. I have brought some more. Second part is the stainless steel box here. And with laser welding, a seam quality can be achieved that makes it possible that rework can be reduced a lot. Or maybe we can even eliminate it. No more rework. This weld seam can be welded within 30 seconds the part comes like this out of the machine. Zero rework is required, and that saves a lot of costs. Yeah, so a lot of arguments, right, for the laser welding, right? Yeah, and you brought something else, right? Yeah, a third sample, of course, with laser welding, also different material combinations can be welded, or materials are normally, say, very difficult to weld, or special geometries even. Here, for instance, we have a stiffening profile, right, a reinforcement with a cover sheet. Reinforcement profile needs to be welded from one side. Challenge is, though, to make sure that we see nothing on the other side, no impressions. As you see, that is possible with laser welding. Here, no zero. So zero rework is necessary, no polishing, no grinding, nothing. Oh, great. That sounds very good and very convincing. But maybe the customer is not quite sure what would be the correct tool, the correct technology for my requirements. So what would you advise him? We have a very, competent team, sales experts, and of course we will consult intensively our customers, starting with the correct design, fixture design, also the technology selection, and also then specification of the machine. So I can only invite you, please contact us. Come here, come to Ditzingen. See, like Chris, you're very welcome to come here to test the programming yourself. And then you'll be convinced, see very easily how easy robot programming can be. You're very welcome. See, yeah. So we will see who comes here, and who will join us. Thank you so much, Christoph, to give us an overview about those two methods. And laser welding seems to be a very interesting topic. So let's stay here and let's now talk to our second expert, Svenja. You are working with the 3D laser systems. What exactly does that mean? Our 3D laser system are 5-axis machines. Unlike the robot solutions, here the 5 axes are composed from 3 linear axes. If you imagine, it's like we have a machine body, and on it a cantilever moves, which then is responsible for the movement in X, Y, and Z direction. And then this is accomplished with a rotary and a pivot axis for the optics. So we have 5 processing axes. So please, would you tell us something about the True Laser Station 7000? What is possible? Welding here. Our True Laser Station 7000 is our smallest machine for welding. And despite its very compact, design, it's very compact and small, it offers a huge variety of different options. I think we have a short video here to show you. Exactly, True Laser Station 7000 offers a very modular design. So depending on the customer's requirements, various optics can be selected and configured, and also different laser types, laser sources are available for the machine. With these, many laser types, it becomes possible that not only the mild steel stainless, but also material like copper or plastics material can be welded, or even a material mix. Yeah, and those, we have a lot of high variety, and also many components from the high-end segment, right, are available. Yeah, also for our starter machine, we offer a lot of welding functionalities that normally the high-end segment contains. For instance, the function Bright Line Weld, our technology for spatter-reduced welding, or also our image processing Vision Line Detect is also available on the machine. And how Vision Line Detect looks like, therefore we can also show you a video. Vision Line Detect, the image processing, corrects small inaccuracies when it comes to weld seam correction. So features need to be programmed, and later the weld seam can be aligned here. Before each weld process, the image processing looks for features and will automatically make a correction, so that we can weld always at the exact position. And the machine then becomes ideal for flexible parts, so ideal for job shoppers, but also for large serial production in an automated way. Now, you talk of large serial production. The True Laser Station 7000, how is it here? We're talking about large, say, serial production and automation components. Herefore, we offer, say, different configuration levels depending on the production environment. The first level would be here the laser machine itself. Means the welding process will automatically be taken over by the machine. Loading and unloading of the parts needs to be done by an operator still. And that, of course, that takes time and money because we have the intervention by the operator. It's not that efficient, right? Yeah, I mean, the target is, when we're talking about large serial productions, that we reduce these downtimes. And that would be the next level of automation that is possible here. And with a new automatic rotational changer that the True Laser Station 7000 can have, that makes it possible. And what would you guess? What will we have here? A video to clarify this. Yes, exactly. With a new automatic rotational changer at the station, it's possible that now, while the machine is producing inside, on the outside, we can load a new part. As soon as the production process is completed inside, the machine can rotate the rotational changer 180 degrees and then resume welding while outside. The next part can be loaded. Oh, that's very good to see here how the machine, same operator, but more parts can be produced for the hour, right? That increases efficiency, doesn't it? What would be a next step of automation here? The next level of automation, higher automation degree, would be loading, unloading through a robot. So either we could do a combination with a rotational changer or just with a lift door machine. We see this also in the next video, right? Here we have a very good, successful project from a customer from the medicine technology. Here we see how the robot will automatically load and unload the parts. Here in combination with a lifting door machine. And thus, in an automated way, large serial can be welded. The customer has also the possibility that the rotor changer can be removed. The robot can be moved away from the machine in order to process larger or different machines, and then back to large serial production, the robot can be attached again. So many options, right? Large, a lot of options he has here. So what are the possibilities here for the customer in cooperation with TRUMPF? If you want to stay flexible for the future, it's also possible when we think of our 3D cutting systems that here, our True Laser Cell 5030 as our flexible starter machine into the 3D laser processing world. And since the latest development version, it is possible now that we can use this machine also for welding. So, and just the processing head needs to be changed. Herefore, we also have a video. Have a look. Yeah, we see the machine is cutting at the moment. Optics change. Now cutting process is completed, and we can just dismantle. Let's see the cutting head, and then flange mount the welding head here. Yeah, we have a magnetic coupling that makes it easy. It's like an objective lens on the camera, isn't it? Yeah, it's similar. And then the machine can weld, produce with a different procedure here. Great. And Christoph invited us to have a look at laser welding here in Ditzingen, right? They also have a similar invitation? Yeah, of course. I would also like to welcome you here. So I'm inviting you to come here, visit us, come here to Ditzingen. Then we'll be very happy to do different tests on the parts, and we will consult you. So we're always available to assist you and help you. Thank you so much, Svenja, to give us an insight into the 3D laser systems. Thank you to our expert. Thank you, audience, for listening. But please stay tuned. Stay with us.